All right, welcome to day 8. What a great day. All right, what a great day. All right, so with this, we're going to go over the X ticket from day 7, which I think went really well. I'm going to predict the future here, okay, because I've obviously taping this in advance. I would have predicted that it went really well. Okay, so we have 7, and we're going to divide that by 1/5. So I need to do what I did yesterday, which was keep, change, flip. And I flipped it to the number 5. 7 times 5 gave me 35. Next, number 2, 1/3 divided by 8. I keep the 1/3, I change to multiplication, and I flip it to 1/8. Therefore, 1/3 times 1/8 gives me 1/24. 1/24. Gotta put it in a decimal. We don't want to put in a decimal yet. Not yet. All right. So 1/24. 1/24. Ugh. Okay. Moving forward to what we're doing today is decimals. Woo! Get excited. I know I am. Where'd it go? All right. So we are solving. I'll show you the first part. We are solving 3 3/10 times 1 6/10. Now, yes, there's a couple different ways to do this. I could have stack them on top of each other and did it the old-fashioned standard algorithm way, but I really think this will make it a little bit easier for you, because the most common mistake doing that strategy, the strategy our parents know, is the placement of the decimal. Okay. So, and there's also a couple other errors like multiplication mistakes that happen along the way. So with that being said, we're going to change each of these decimals into fractions. The way we're doing that is we're looking at the last place value, the number that has a number in it. Obviously, there's other place values here that you can't see because they're invisible, like the 100th has a 0, the thousandth has a 0, but we're talking about the place value that has the last digit in it, okay? Which is a 3, which is the 10th place. So my 10th is going to be my decimal for both. So you have a 10th place, 10th place, 10th, 10th. And then if I were to pull that decimal out, what's that number? 33. If I were to pull that decimal out, what would that number be? 16. So now I have a fraction times a fraction. I'm going to do 33 tenths times 16 tenths. I'll get 528 hundredth. What, Mr. Brislin? How did you do? You didn't do that in your head, did you? No, I didn't do it in my head. All right. What I did do, okay, is I took the 33 and I expanded the 16. And I got 330 here, and I got 198 here. And then I added them together to get 528. Ta-da! Okay, when I did that, I then divided it by 100. And you're saying, Mr. Brislin, why are you doing that? And some of your family members at home are saying, why are you doing that, Mr. Brislin? Isn't there just an easier way to do this? Yes, I'm going to show you the 2 different ways, hence the fact it says or. The first way, I think, would be some really good practice to give us an extra boost of confidence when it comes to dividing long division, especially when you have to go into decimal territory. All right? So 100 goes into 528. Where'd that 100 come from? Remember, it came from the 10 times the 10, giving me 100 as your denominator. Now, we're going to see how many hundreds go into 528. Well, 5 hundreds go into that, which gives me 500. I subtract, and I get 28. I bring down a new place value that's not there visibly. It's invisible. I bring it down. I get 228. 200s go into 228, which gives me 200. I subtract, I get 80. I make another place value, and I bring that down, and I get 800. 800s go into 800, meaning there's nothing left over. Poof. Now, that's this strategy. But I have a feeling a lot of you would rather do it the other way. The other way is turning this fraction into a division expression of 528 divided by 100, and then just shifting. Okay, so how many shifts are there? 2. Okay, it's just like saying 528 divided by 10 to the second power. Oh, Mr. President, exponents again? Yes, exponents again. All right, it's good practice. So shifts 2 times. So the 5 shifts over and twice, and everything follows it, and gives you the answer of 5 and 28 hundredths. A lot easier, isn't it? All right, so let's move ahead to our next problem. All right, I'm only going to give you part of this, and I want you to finish the rest. So 4 and 4/10 times 3 and 2/10. I've already converted it for you into fractions. Now go ahead and do the rest. Hit the pause button at this time. Did you get this far and then get stuck? That's okay. Okay, you should have hopefully gotten 1,008. Once again, you could have done this. The next step would be the standard algorithm, if you chose it that way. I'm trying not standard algorithm. The long division. I don't know where I guess I did standard algorithm. Long division. Okay, you could have done it that. You could have done the long division. Would have been the next step, or you could just shift. I gotta make lots more place values here. 2 shifts. 1, 2, 14, and 800. All right, let's try. You know, it's peeking out at you over there. Let's try solving this problem. 2 and 2/10 times 1/6. Go ahead and do that now. All right, so I hope you did get 352. If not, fix that now. Hit the pause button right now and continue following the steps it takes to solve this problem. All right, if you didn't get it, if you did get 352, what did you do next? Well, I hope you took the 16 and you broke it up to be a 10 and a 6. When you did the 352, to get the 352, you should have done that. Okay. Then I hope you could have used an algorithm, or you could have just shifted the 352 over 2 spots to get 3 and 52 hundredths. And there we go again, saying standard algorithm. Oh, long division, the long division strategy here. Notice how I brought place value down 1 time and had to bring it down again. All right, last problem. Three and 35 hundredths times 7/10. Go ahead, hit the pause button and do that now. So some of you out there are finally, I think, getting how to turn this into a fraction. Okay? Once you figure that part out, it really, everything else becomes a lot easier. And I think then I hope you were able to find, because you're doing a 3-digit times 1 digit. So you didn't have to pull anything apart. So I really hope you were able to find the answer here is 2,345 over 1,000. Now that is a common mistake I think some people would have made. They would have just gone used to putting 100 there because every problem before that, the denominator was 100. Well, that just goes to show you didn't understand where we got the denominator from. The denominator came from this denominator times that denominator to give you, in this case, 1,000. If you're not quite sure where your multiplication mistake was, if you made one, when you got 335 and times it by 7, here is how you get 2,345. 5 times 7 gives you 35. 3 times 7 equals 21 plus 3 equals 24. 7 times 3 equals 21 plus 2 more gives you 23. Now, I have a feeling most of you are going to prefer using this strategy of just shifting over. So I'm not going to bother to show you the standard algorithm strategy here. I really feel like most of you are preferring this strategy, which is fine. Okay, shifting it over I think makes it a lot easier, less errors. Okay, so in this case I'm shifting over 3 places because it's saying 2,345 divided by 10 to the 3rd power technically is also what you could call it. And you get 2,345 thousandths. Small number. Okay, so with that being said, go ahead and let's get started on that exit ticket. Unless you don't feel confident yet. If you don't feel confident, take some time, review this video again, and then do the exit ticket. I don't want to force you to do the exit ticket if you don't feel confident yet. Maybe you need to make up your own practice problems to check and have somebody at home check. That would be wonderful too. All right, best of luck, and we'll see you back here tomorrow.